All right, everyone. Welcome to today's live session. My name is Suparna, and today you all know that it's a very special day for us. February 11th, we are celebrating Women and Girls in Astronomy Day. Okay, so which is organized by International Astronomical Union. So I hope you all know that we are celebrating this today, and this special day is we are celebrating because this day is really about recognizing women who contributed so much for astronomy. Okay, and not only for that, and also to inspire the next generation of women scientists and engineers. So this is a very special day, and STEM and space. Okay, so SMS Space, that means us, we are celebrating this day with this session, Women in Astronomy. So today's session, we will be talking about some of the well-known women astronomers. So we will be going through their story and learn what are the different challenges they faced, what they achieved, and how their work changed the way we understand the universe today. All right. So, but before we move ahead, I have a small, quick, basic question to all of you. So you can answer that in the chat. All right. So the question is, what do we mean by astronomy? So today we are going to discuss women in astronomy. We know that there are topics like biology, which is the study of living organisms, or we know botany, which is the study of plants. So what do we mean by astronomy? So let me know in the chat. Okay. Hi, everyone. I can see everybody is just warming up. What do you know about astronomy? Yes, it's the locating of stars. I can see some of the answers. Let me know, everyone, quickly. Let me know, like just whatever comes in your mind, you can, type that. Study of space, positioning of stars, astronomy is a study of the universe. All right, so though we got a lot of nice answers, and yes, all of you are actually correct. Okay, so astronomy is basically the study of celestial objects and phenomena that occurs in cosmos. So it's very complicated. So the definition is a little complicated, but it's a very simple thing. So basically, it means it's about understanding things like stars, okay, or planets, or moon, or even galaxies. Okay, and everything be happening beyond Earth. Basically, everything happening beyond Earth is called as, if you are studying about it, it's called astronomy. So what these objects, how they form, how they move, and how they change over time, all these things are discussed in astronomy. And we know that humans have always been curious about this particular topic, right? And when you look back in history, not everyone had the same freedom or privilege to ask the even ask questions about our universe. Okay, and that category of people were women. Okay, so a lot of women struggled, they were discouraged, some of them kept out of education, not some of them came out of it, they were not taken seriously. So there were like a lot of problems women suffered from history. And when we say this is the story of women who asked them anyway, this means we are talking about some of the women who didn't let these stop their curiosity towards astronomy, about our universe, despite of all these barriers and struggles. Okay, and one of these earliest examples of this is none other than Hypatia of Alexandria. She is the first non-women astronomer of the world. Okay, so her story, she is actually, she lived in a very olden times. That means she lived around 355 to 415 AD. So around 1600 years ago, in a city called Alexandria. So some of you already know about Alexandria. But at that time, Alexandria was one of the biggest centers of learning. So there were many philosophers, there were many astronomers. They were studying and also teaching their philosophy and astronomy. So Hypatia, she was also very interested in mathematics and astronomy. And not only that, she studied all these subjects, she also taught these subjects. Okay, so she was actually a teacher and she was well respected in that place. Okay, so she used one instrument called astrolabe. Okay, so this instrument is to make astronomical measurements. So to calculate the altitudes of celestial bodies, or sorry, or to calculate latitude and all the other measurements. So she actually studied how to work this instrument. She taught this to so many people. So this is a crucial instrument, because while studying with this instrument, people can track season. This people can understand different navigational. They can use it for navigation purpose. They can use it for timekeeping, and basically to help them for agricultural purpose, because we know the stars and constellations and all those things help in finding the season, and that will in turn help them for agriculture purpose. So even though many people respected her, there was a lot of tension during that period of time, because because it was a very dangerous, we can say dangerous political time. So because that time people with knowledge, or people who spoke up, were seen as a threat. Okay, and sadly she was attacked and killed. So not because she did anything wrong, but because she wanted to study and share her knowledge with the world. So Hypatia, it's a sad story, but she was not just a part of history. She was just a beginning. Okay, we can consider her as a starting point of all the achievements made by women in astronomy who came after her. Okay, and when you move when you move a little forward in time, you can start seeing, like in 1700s, you can see small changes happen. So society was not that strict about women teaching astronomy or women entering into some careers, but still women were not actually encouraged to study space. Okay, it was but even all these problems were happening, some brave and determined women actually came up and fought for it, and one of them was Caroline Herschel. Okay, so I don't know if you know about Caroline Herschel, but if you know about her, let me know in the chat. Okay, so just drop a yes or no if you know Caroline Herschel. Okay, so her story is interesting because when she was very young, from that time she was very curious. Okay, she was curious about stars and planets. She was questioning everything, but her parents and the society around her, they said, you're a woman, you can't achieve anything, so just drop all these questioning and everything. But later, when she became a little older, she moved to England. Okay, and she started working with her brother, who was William Herschel. So I hope you all know about William Herschel. He was a very famous astronomer. So Caroline Herschel was actually a sibling of William Herschel. So at first, when she moved to London, she was helping her brother with the work. So morning time, during daytime, she was doing all the household chores, cleaning the vessels, cooking, and also sweeping the floor and all those kind of household work. But at night, she was using the telescope to actually observe the night sky. She was very curious. Okay. And that's when she made some incredible discoveries. She actually discovered several comets. So she discovered around 8 comets. One of those comets was actually named after her. Okay. And not only that, she also worked with William Herschel to create a detailed star catalog. So this is astronomers' map. Okay. They can, this will help astronomers to map the sky more accurately. So she did all those things. Okay, so first she was facing a lot of opposition, but eventually her work was officially recognized and she became the first woman to receive a salary for scientific work. Okay, and that doesn't stop there. To honor her, even today, her name is given to so many things to honor her contribution. Like there is an asteroid named Lucretia. Okay, so this was named after her. There is a crater on the moon called C. Herschel, short form for Caroline Herschel. Okay, and there is a star cluster which is named after her. It's called Caroline's cluster. Okay, so you can see she was going through a lot of struggle, but the end, her legacy and her contribution is well noted, and she is getting a lot of attention now also. Okay, we are honoring her in so many ways. Now, if you come to the next part of the history, you can see women already started coming out and publishing their work. Some of them started astronomy as their profession, and that's where our next astronomer comes in, who's Maria Mitchell. Okay, so it's happening in 1800s. All right, so she was the first women professional astronomer of US. All right, so her story is also very interesting. She actually found a comet. Okay, so when she was observing the night sky, and she found a comet in 1847. And that comet later known as Miss Mitchell's comet. Okay, and that made her very famous. But she didn't stop there. She was more interested in learning about sun. So what she did is she spent a lot of time studying sun. Regularly, she observed it, and she took a lot of photographs of sunspot. I hope you all know what is sunspot. Okay, so she wanted to study about it, and nobody was actually studying about sunspot at that point of time. Okay, and also there was a myth going on during that time. They all thought these sunspot were shadows or clouds on the sun. Okay, so then after a lot of studies, Maria Mitchell, she actually, after spending years of research, she understood that these are not clouds or shadows. These tiny spots are powerful magnetic regions of sun. Okay, so this looks black because those areas are cooler than the other regions of the sun. Okay, so this is very important discovery because it helps scientists to realize that sun is not a very calm and perfect place where they can find clouds. Okay, it's a very active and constantly changing star. Okay, so this is actually a very big contribution Maria Mitchell did to the Astronomical Society. But despite all these achievements, even though she has a lot of achievements, there was still an inequality. Okay, she was paid less than her male colleagues simply because she is a woman. She was doing the same effort, she was doing everything, but she was getting less money. But she did not stop there because though she was facing inequality. She didn't stop there. She did a lot of research, she continued teaching, and she also spoke openly about fairness and equal opportunities. Okay, so that's what makes her a very, very important personality in astronomical history. Okay, so now coming back to 20th century. So as we move from older times to modern time, we can see that more and more women entering into the field of astronomy, because these people who are in the past, they contributed so much, they went through a lot of struggle, and they pushed astronomy so much that a lot of women, they came up from their comfort zone and they started learning this astronomy. So then, yes, they still face challenges, but they were also making extraordinary discoveries by playing key roles in space exploration and different fields of astronomy. And that brings us to our next astronomer, Katherine Johnson. So I hope some of you already know her name. She is very famous. She is known as the human computer. Okay, so she is someone whose amazing calculations helped astronauts get into the orbit safely. Okay, So let me just tell you a little bit about Katherine Johnson, then I will show you our podcast. So she was an African American woman. She was working at NASA, and that time, women and also Black people were facing serious discrimination. Okay, so she was actually a victim of racism. Even though she was extraordinarily talented in mathematics, she still had to work hard to get recognized and to taken seriously. Okay, so we have a podcast channel called Stories of the Universe, where we have so many interesting podcasts. But one of them is about Katherine Johnson, and we have so many new episodes also coming up. So let me show you a short clip of our podcast about her. Just a minute. Yeah.
Greetings, space explorers. Captain Sky here. And today I'm going to tell you about someone who reached the moon without ever leaving Earth. Her name was Katherine Johnson. And this is the story of how a young girl who loved to count became the woman who calculated the path to the stars. But first, let me take you back to a time when computers weren't machines, they were people. Our story begins in 1918 in White Sulphur Springs, West Virginia. Little Katherine loved numbers more than toys. She counted steps to church. 273 steps. She counted dishes. 24 plates. She counted stars through her bedroom window until she fell asleep. But here's where it gets amazing. When Katherine was just in first grade, that is, when she was just 6 years old, she was already solving math problems that were meant for older kids. Her teacher would write problems on the board, then turn around, and Katherine's hand would shoot up.
I know the answer! I know the answer!
The teacher would shake her head in disbelief.
Katherine, I just wrote it. How did you solve it so fast?
And little Katherine would smile and say,
Well, I just counted in my head.
So yes, it's a very, very interesting story. And please do watch this completely on our podcast channel, Stories of the Universe. Among this, we have a lot of other interesting podcasters. Okay, so we will be sharing the link in the chat. Yes, Garvit sir already shared the link in the chat. So please do watch it. It's a very inspiring story. Okay, so now coming back to Katherine. Like I already told you, her calculation made sure the spacecraft should launch correctly and go into the orbit. Most importantly, these calculations help astronauts to come back to Earth safely. So just imagine for a second that was a time when computers weren't as powerful as they are now. So all the math she did had to be absolutely accurate. She worked in a lot of interesting missions, like in a lot of important missions, like the Mercury missions, including John Glenn. I hope you all know about John Glenn. John Glenn's famous orbit around the Earth. So she is the one who actually calculated the trajectory or the path of that spacecraft. Okay, and later her math also helped and used in Apollo missions that took astronauts into moon. Okay, so she is a very important and unique personality. She helped in a lot of contributions, like we can say human contributions, like the trip to the moon and all these spacecraft which is working now. It's because of Katherine Johnson in a way. Okay, so now after this we can see something really important. So after Katherine Johnson's period, women were not just entering into one area of astronomy anymore. So they were spreading into different fields of astronomy. And that's where our next astronomer comes in, who is Jocelyn Bell Burnell. Okay, so her work completely changed how we study our universe. So when Jocelyn Bell, when she was a graduate student, she was doing some observation. She was collecting data, and she was observing. She was regular, like a regular student. She was just doing her work. So suddenly she noticed something interesting. She noticed that there is something strange in her data. She was getting some signals which were super regular, but almost like a heartbeat. Okay, heartbeat is regular. So similarly, she got a signal. So after studying them carefully, she understood that these signals are coming from something called as spinning neutron stars, or something called, it's known as pulsars. So how many of you know, have you heard about pulsars? If you know what is pulsar, let me know in the chat. Okay, so if you know about it, give me a yes or no. All right, you don't have to write the entire, what is pulsar. So we all know that stars have a life cycle. They born from a place called nebula, which is a cloud of dust and gas, and then it goes through different stages. That becomes a protostar, then it becomes big. It goes to the red giant or red supergiant phase. So at some point, when the star comes to the end stage, it explodes. So the stars which are bigger than our sun, that explosion is called as supernova explosion. So after supernova explosion, all the materials around this star will just spread into the space, but the core will remain there. Okay, and because of the gravity, these cores can collapse and become super tiny and super dense object called neutron stars. Okay, and sometimes these neutron stars will spin very, very fast, and that sends out some small beams of light, radio waves. Okay, small beams of radio waves, and that's when we call that neutron star a pulsar. Okay, and Jocelyn was actually saw a pulsar. She is the one who discovered pulsars. Okay, so it was a huge discovery that changed the way we understand universe. But there is another frustrating part. When the Nobel Prize was awarded for this discovery, it went to her supervisor, not her. Even though she was the one who noticed and analyzed the signals first, she didn't get the Nobel Prize, but that didn't stop her. She continued her research. She made more and more contributions to the astronomy. In all these stories, if you're starting from Hypatia to Jocelyn Bell, you can see that these women who didn't give up. Okay, they had a lot of struggles. They came up with a lot of barriers, but they overcome all of that. Okay, and they are the people who led path for all who came after them. Okay, so there is a reason why they are the reason why there are more and more women in this astronomy fields currently, because of all their struggles and contributions. Okay, so now let's move on to another incredible women astronomer, Vera Rubin. So I hope some of you must have heard her name. She is the first woman. She's the woman who found the invisible. So let's see, that is actually a little mysterious, right? So let's see, what do we mean by invisible? So Vera Rubin was working in Kitt Peak Observatory in Arizona. So she was actually, taking observations in that observatory. But while she was mainly focused on galaxies, especially in spiral galaxies. So while she was studying these spiral galaxies, she understood that some of the stars which is in the outer part of these galaxies are moving very fast. Okay, so the outer stars moving very faster than they were supposed to. So if you're taking the normal physics, they should have slowed down because it's far from the center. The gravitational force should be less. So in a way that they should move around the center at a very low speed, but they didn't. Okay, so that was something mysterious she found. So this made Vera realize that there is something invisible out there which is holding these galaxies together. So during that time, scientists were calling something called dark matter. Okay, so there was no evidence for it. They said the universe mostly made up of dark matter. So we know that all the matter, like all the planets, stars, whatever you can see, all those matter, if you add all those things, you will get only 20% of our universe. Okay, so that makes up all the things you see around you, everything. If you add up, it will just make the 20% of our universe. All the other 80% is something called as dark matter, which is not visible to the naked eye. And it gets affected by gravity. And Vera Rubin's observation was some of the strong evidence for this. So scientists already had idea, but there was no evidence. And Vera Rubin is the person who actually came up with a strong evidence for dark matter. Okay, so now we know that to honor her groundbreaking work, we have our observatory called Rubin Observatory in Chile. It's named after her. Okay, so this observatory is one of the most advanced observatories in the world. So this is helping astronomers to study galaxies, dark matter, and even the universe completely. And this is actually an image of one of the clearest image of the universe taken by this observatory. All right, so these contributions are very, very big, and they are honored. Their names are honored. Till now. Now, while other countries are achieving in so many levels of astronomy, our India is also not behind. Okay, so one of the most amazing things we did in our space exploration is the Mangalyaan mission. I hope everybody know about Mangalyaan mission. Okay, so this, and honestly speaking, some of the most important people behind this mission were women. Okay, so if you look at the screen now, yes, these are the women who actually took, India to Mars. So scientists like Ritu Karidal, Nandini Harinad, Anuradha Tiki, and there is another person called Minal Rohit. So they played key roles in different fields of this mission plan. And there are so many other brilliant women in ISRO who contributed behind the screen also. Scenes also. So I hope some of you are already watched that movie called Mission Mangal. If you not, just please watch it. It's about our Mangalyaan mission and the struggles they faced during that phase. So that movie is actually inspired by these amazing women and this Mangalyaan mission. Okay, so and that's something very amazing about this Mangalyaan mission is that India reached Mars on the very first attempt. So most countries will take multiple tries. They sometimes fail the first few times, and then we did it right away. So it was a huge success and achievements for our Indian space program. And also you have to understand this Mangalyaan mission was the budget for Mangalyaan mission was less than some of the movies. Okay, so looking at all these amazing work of women from ISRO, or you can really see how women have been fighting for years to be recognized in the science, but now we are at a point where their work is celebrated all around the world. Okay, so that brings us our next astronomer, Katie Bowman. Okay, so she was actually a computer scientist and an engineer who worked on a very special project. I hope you can see it from my screen itself. You can understand what she contributed. She was actually, in the project where we took the first ever image of a black hole. Okay, so for those who don't know, black hole is actually a region in space where the gravity is so strong that even light can't escape from it. So if there is no light coming out of it, it's very tough to take the image of that particular thing, right? So it makes impossible for for us to take photograph of these black holes directly. So scientists had to get creative. So what they did is they used, instead of using one big telescope, they used a network of telescopes. Okay, so all around the world, they in so many places they kept telescope, and that was called Event Horizon Telescope. And they combined all those data from these telescope and and combined them. So basically, it's actually, we can say, a telescope which is actually in the a size of the Earth. A telescope the size of the Earth. Okay. Now our Katie developed a proper program or algorithm, and that made it possible to combine all these data from these different telescope into one clear image. Okay, so her work was crucial to turn years of research into a proper image of black hole, which came out, which was released in 2019. Okay, so I hope you all understood about Katie Bowman. So this achievement is incredible, not just because it gave us the first ever image of a black hole. Okay, but it's important because it shows how women in science have been working, learning, and breaking barriers for years. The struggles they go through and everything, and at the end, now women are there in different fields of astronomy. Okay, so when we look at these amazing women, from Hypatia to Vera Rubin to the women in women in ISRO, and now Katie Bowman, and so many other people, this is actually a very important big lesson for us. Okay, so it's very simple. The lesson is very simple. So you just have to stay curious. You just have to keep asking questions, keep learning, and just keep trying. Hard work pays off. So if, yes, there will be struggles and barriers, but if you don't give up, and you can still achieve these great incredible things. So let that be the main takeaway from today's session. So I hope you all enjoyed today's session, and please take a look at our podcast channel. It's a very interesting podcast channel. And so yes, one more announcement I want to make. So those who participated in NAC, your results will come in mid-March. Okay, so that is also one of the announcement. You will get it. It will be announcing, and we will let you know once it's announced. Okay, so yes, that's it, everyone. Thank you all for joining. Let's meet you all in another session. Till then, bye-bye.